9.7 Properties of integrals. The first property is multiplication by a constant. If you have an integral of a function multiplied by a constant, you can take that constant out. That's equal to the constant times the integral of the function. In other words, the integral of c f of x dx, where c is a constant, is equal to c times the integral of f of x dx. For example, the integral of 3 times cosine x dx, 3 is a constant, so that's equal to 3 times the integral of cosine x dx. The integral of cosine x is sine x, so this is equal to 3 sine x plus our constant. Okay? That's it. Second property, sums and differences of integrals. The integral of f of x plus the integral of g of x is equal to the integral of f of x plus g of x. Same for subtraction. The integral of f of x minus the integral of g of x is the integral of f of x minus g of x. Why is that true? Well, here's the integral of f of x. Here's the integral of g of x. F of x plus g of x, well, we're just adding those lines. If here's f of x, here's g of x, when we add them, it just gets larger if they're both positive. So we can always just add the areas. When you add the areas, we get this. So that's why it works. So example, integral of x squared plus 4x minus 3. Well, that's equal to the integral of x squared dx plus the integral of 4x dx minus the integral of 3 dx, which is equal to 1/3 x squared. We're going to put the constant at the end, plus 2x squared minus 3x plus c. Okay. For the rest of this course, you can just skip the step where we write out the separate integrals, but we know that's true. The reason why we can do this is because the integral of a plus b is the integral of a plus the integral of b. Same with multiplication. Same with subtraction. Okay. Next, here are some properties involving definite integrals. Here's the first one. The integral of a to b of f of x dx plus the integral from b to c of f of x dx is equal to the integral from a to c of f of x dx. What do I mean by that? So for example, the integral of 0 to 2 plus the integral of 2 to 5 is just the integral of 0 to 5 of whatever function we have, which in this case is 0.5 x squared dx. Okay. If we finish this, we would get 0.5 over 3 x cubed from 0 to 5, which is 0.5 over 3 times 5 cubed. Okay? Why is this always true? Well, we can look at it this way. The integral of f of x from a to b, that's just equal to big F, the antiderivative big F of b minus big F of a. Right. For example, the integral from 0 to 2 is the integral of 2. It's the integral evaluated at 2 minus the integral evaluated at 0. So integral from a to b is the integral evaluated at b minus the integral evaluated at a, which is big F b minus big F a. Next, we have the integral evaluated from b to c. That's big F c. Again, big F is antiderivative minus big F b. But then the big F of b minus big F of b just cancels. That's big F of c minus big F of a. and that's just equal to the integral of a from a to c of f of x dx. So that's the proof. Proof shows that it's always true. Okay. Next, what happens if we, actually let's look at the graphs on decimals. So here's the function from 0 to 3. The function is 0.5x squared. It's the area under the curve, that's the integral. Here's the same function from 3 to 5. If we add these two integrals, that's the same as the integral from 0 to 5. That's all that means. We're adding two areas, so that works. Okay, last one. Reverse limits of integrals. The integral from a to b of f of x is equal to the negative of the integral from b to a of f of x. For example, the integral of 3 to 7 of e to the x over x squared dx plus the integral from 7 to 3 of e to the x over x squared dx. Well, we actually don't know how to integrate e to the x over x squared, but the integrants, the two limits, one is going from 3 to 7, one's from 7 to 3, the intervals, the ends, they're opposite. So they're opposite of each other. In other words, this is the same as 3 to 7 e dx over x squared dx minus, we can switch the two ends. So 3 to 7 again, but it becomes negative x squared dx. So it has to equal to 0. That's equal to 0. Okay? That's all it means. We can switch the two limits and make it negative. Why does it work? Here's the proof. The integral from a to b of f of x dx is just equal to our antiderivative big F of b minus big F of a. The integral from b to a of the same function is equal to our antiderivative of a minus antiderivative of b. So they're opposite of each other. So one is just the other times negative 1. Okay. All right. That's it.